Okay, so hello everyone. Thanks for joining. I am Tomas. I'll be the host for today's session. And welcome to the webinar on how to analyze and optimize mobility with geospatial data. With me is Alexi. Can you please move to the next slide? So I am Tomas. As I said, I'm a solutions engineer. Been working in CARTO for around a year and a half. Been working in geospatial for around 5 years, and with me is Alexei Bielov, who's a product manager at Snowflake. He will introduce himself shortly, but he will be helping out with understanding how to work with Snowflake and Geospatial. So if we go to the next slide, we will see the agenda for today's session. The idea of this whole webinar on this session is to understand some context on what is Snowflake and how it came to be. Same thing for CARTO. What is CARTO? What does the CARTO platform? Why does it exist? And how those two things work together to solve geospatial problems. So we'll give some short introduction on the two platforms. Then Alexi will guide us through how to work with geometries, specifically within Snowflake. And then he will introduce us a use case of ride-hailing, of a ride-hailing app. So he will talk briefly on how the infrastructure might look like for a use case such as maybe a Uber Drive application. Then I will build on that use case to showcase some of the Snowflake plus CARTO capabilities on spatial analytics, and we will build 2 live demos on that. And then we'll wrap up the session with a real use case that leverages Snowflake and CARTO for human mobility. And then we'll just leave around 10 minutes at the end for Q&A. So please feel free to drop any questions in the questions section in Zoom, and we will address them at the end. So that's the idea for today. With that, I will pass the word on to Alexi so he can start talking a little bit on Snowflake.
Thank you, Thomas. Hello, everyone. My name is Alexei Belov. I'm a product manager for Geospatial Analytics in Snowflake. And I will start with high-level overview of the Snowflake Data Cloud. Snowflake was founded about 10 years ago. Actually, 10 years ago, we celebrated our 10th anniversary this year. And today, Snowflake is a data platform and content. So data platform has data warehouse in its core, and we support pretty much any type of data. We support structured data, unstructured data, semi-structured data, and even streaming data. And we can work with them in OLAP fashion and in OLTP fashion. So if you need to work with data in transactional format, then we can provide this as well via Unistore that we currently have in our private preview. Also this year, actually not this year, that in general we provide features for data scientists, for data engineers, for data engineers to build the ingestion pipeline, ETL pipeline. Data scientists could build machine learning models and publish them and use them in production. And anyone who works with cybersecurity and interested in analyzing risks and vulnerabilities, they also can find features in Snowflake. And of course, anyone who wants to share data inside their organizations or outside of their organizations, they definitely can do this with help of collaboration capabilities. So it's a platform and content. And what Snowflake does to enable geospatial analytics. So we have a geography data type and around 60 native functions that work with this data type. We have GeoJoins, really fast and efficient, and we invest in speeding up our joins a lot because we strongly believe that data brings more value when it's joined from different sources. Like, for instance, transactional data can be joined with market data or some census data. And for those who have very specific use cases and need some functions that we don't provide out of the box, they can use Snowpark UDFs. They can build their user-defined functions using Python, using Java, using Scala. And I'm really big fan, for instance, for Python UDFs, because like with them, I can get the whole power of Python libraries such as GeoPandas, GDAL, Shapely, and etc. And delegate them to the side of database. So basically they run in containers, in very fast containers, and you can embed them into the SQL code. And if you go even beyond that, you can build the native data applications. Like recently, Snowflake acquired company called Streamlit, and with Streamlit you can build the data applications really easily. So like you can build the dashboards, or not related necessarily to Streamlit, but also you can build, for instance, you create your own model and publish it and share this model in our marketplace. So what's new? We currently have a public preview of geometry data type and fast GeoSearch, and both those features currently in public preview. And to explain the difference of geometry data type to geography, so geography we already have in general availability for about a year and a half, and it supports most commonly used special reference system WGS84, and assumes that the Earth is a sphere, and all the calculations they run applying the spherical math. In case of geometry, we have more flexibility for working with different special reference systems. Basically, we support all of them. And at the same time, calculations on geometry data type might be faster, not might be faster, are faster, because we assume quite simplistic view of the world. So Earth is not a sphere, but actually a plane. And all the maps are projections from the sphere to the flat surface. And geometry currently, as I mentioned, in public preview. Besides geometry, we have a public preview for fast search. And when you can use it, if you run some queries where you try to find objects by their coordinates, or by using the bounding box or point lookups. So whenever you run queries with where statement, with ST intersects predicates, or ST contains, or ST within, those queries can benefit from the really fast GeoSearch, because like under the hood we apply special indexing, and CARTO build a feature which they call dynamic tiling, and based on their feedback, the performance of this feature speeds up from tens of seconds to like single seconds after applying search optimization. And now, mentioning CARTO, I'm over back to Thomas.
Thanks, Alexi. That was pretty interesting. So for those of you that haven't heard of CARTO before, or are not sure what CARTO is a cloud-native spatial analytics platform. And you can think of CARTO as the place to go to solve any location intelligence problem that you're facing. You want to leverage CARTO's technology to solve geospatial problems with the best data and the best analytics. So the way that CARTO does this is through a unified workspace that leverages Snowflake storage and processing capabilities. So we will show a demo on how the CARTO workspace looks and how we work with the CARTO workspace. But basically, CARTO allows you to connect to your data sources, so you can connect directly to Snowflake. It allows you to explore your data and enrich that data with third-party data. So we have a data observatory that enables you to get partly from other providers, that allows you to enrich this data with any sort of data, such as point of interest, human mobility, social demographics, and many more. Then you have a set of analytic toolbox that we will discuss further in the next slide, but it's a SQL extension that gets installed on top of Snowflake and enhances Snowflake's own geospatial capabilities to do massive geospatial processings and also complex geospatial processings. And then we have two links as well for creating map visualizations to have a visual representation of these geospatial analytics. So if we go to the next slide, Alexi, specifically on this webinar, a few maybe details that I didn't mention about CARTO as a more commercial perspective. It's a company founded in 2012. It's present worldwide. Over 200 people now working in the company and over 2,200 clients, I believe. But specifically this webinar, we will be working with the analytic toolbox, which is this SQL extension that gets installed on top of Snowflake. And it's basically a module of over 100 advanced UDF functions, user-defined functions. One thing to mention here is that there's two modules of the analytics toolbox. One is the core module, which is a module that CARTO develops and opens to the community. So this is an open source package. So any attendee here in this webinar that is actually using Snowflake at the moment, you can already go install this package, and even most of the demos that we will do on today's session can be leveraged through these packages. And then on top of that, we have the advanced modules that comes with a CARTO license and enables many more complex and really beautiful massive visualizations. But today's session will be mainly covering some of these analytic toolbox methods, and also the builder tool, which is a tool that we use to create dashboards and mapping dashboards that allows us to visualize and understand the spatial context of our analysis. So back to you again, Alex.
Yeah, thank you. So for this demo, we will imagine that we are working in the company that builds a ride-hailing application. And we are a team of data scientists, machine learning engineers, and analysts, and we are responsible for the feature which called dynamic pricing, or some people call it search pricing. Basically, you might experience search pricing if you open your favorite ride-hailing app in the morning peak hours or in the evening peak hours, and you try to get a car, and you notice that the price is higher than you get used to. So maybe sometimes it's multiplier 1.2, sometimes it's 2. If you're trying to get a car around Christmas or New Year, then sometimes it might be even 3x. And basically, we as a team, we are trying to build a machine learning model that will be predicting search pricing multiplier. And to build this model, we will use as an input market signals. In our case, market inputs would be steps of customer flow. So we have City of New York, and imagine that whenever passenger opens the application, he sees the price, and on this stage already our search multiplier applied to this price. So if he happy with the price and estimated time of arrival, he clicks make a request, and in our system we create a request which we start sending to our drivers. And as soon as one of those drivers accepted this request, we create a booking, and as soon as driver came to the passenger, fetched the passenger and brought him to the destination point, we create a completed ride. And I forgot to mention that actually many people who experience search pricing, they don't really like it. Like, there are many reasons to hate search pricing as a feature, because no one wants to pay more than he get used to. But the fact is that without search pricing, you wouldn't be able to get taxi at all in those morning peak hours or in the evening peak hours, because drivers just wouldn't be enough motivated to drive into the city center where there are traffics, or in the morning peak hours, maybe like drive to some outskirts without the opportunity to get a taxi, to get a passenger from the outskirts to the city center. So we actually should be thankful to search pricing, because of it we can get a taxi in the morning or in the evening. Okay, so how we will do, how we'll aggregate those signals that I mentioned in the slide before. For this, we will use a H3 index introduced by Uber about 5 years ago. And what is the H3 index in few words? It's a way to split the space into areas of similar sizes, like hexagons. And this index has hierarchical structure. So basically, you can set the resolution for every for the hexagons that you will use. And hexagons of resolution 6, for instance, they contain exactly 7 hexagons of resolution 7, and etc. So in our case, to gather data from New York, we will use the hexagon of resolution 8, and we split the city in those hexagons. And for every hexagon, we will calculate the market input. So how many quotes was in that hexagon, how many requests, how many bookings, how many tours. Also, we are interested in information, how many available drivers was in those hexagons. And we might apply some specific technique to calculate drivers, because drivers not staying in the same hexagon, but usually they are driving around, unlike passengers. And another signal that might be interesting for us is estimated time of arrival. And eventually, after this pre-processing ends, for every hexagon and for every minute, we know how many quotes was in every hexagon, how many requests, how many drivers, and etc. And it's important to remember that this information we gather on the minute basis. So for instance, if in New York we have thousands of hexagons, then for every minute, for every hexagon out of those thousands, we gather all those statistics. And if we would build a service using this approach, this service might look like following. We have some source of the raw data. It can be some streaming service. Again, pick your favorite one. It could be Kafka message broker or RabbitMQ. And from those services, we ingest data using streaming ingestion in Snowflake in the table that will contain the raw data. Then we will apply this bucketizing of the geospatial data. And for every bucket, we compute the statistics that I mentioned before. In our case, we will compute one statistic, just number of tours. And from after this manipulation, we save this data in regular tables. And from regular tables, they can be used for real-time business monitoring or for analytics, for instance. Second flow of data transformation, after this bucketizing, we might want to use this data in our live services. For instance, in our machine learning model to train or to predict. And in order to do this, we might want to enrich this data with some additional signals, some additional features. And in our case, let's imagine that find out that our drivers, they are less motivated to drive to the areas with the high level of crimes. And in order to use this information in our models, we decided to enrich our data with crime risk information. And after doing this, we save our data in hybrid tables. So basically, hybrid tables, it's a tables that can work with OLTP workloads, meaning that you can have a really fast searches on index or IDs. On IDs and use this data in live data services. In our case, it can be our machine learning service that built on top of, for instance, TensorFlow Serve. And now I will show you how all those transformations that I showed you on this picture can be implemented actually with the help of the SQL. For this, I will use Snowflake UI, which I usually use to run queries and manipulate with my data. I will do some preparation, select the user, data warehouse. Data warehouse, it's a computation instance or computation cluster that runs all the computations. GeoPlayground is my database. I will use schema in New York taxi. And after ingestion of the data from the streaming service, it might look like this. I just showing this to you so you get a sense of how this data looks like. So we have a pickup time, we have a pickup location, then we have drop-off location, some information about fares and trip distance. In our case, we are interested in number of tours. So as a second step, in order to bucketize this data, we will use analytics toolbox from our marketplace. Here it is. Basically what we will do in this query, we are interested in getting the timestamp, and we are not interested in seconds, we are interested only in minutes, so we strip out our seconds. And every location we will label with the bucket to which this location belongs. So basically we will do bucketizing from geography point, we convert into the H3 index, and then we calculate the statistics for every index. And after all these manipulations, we get in this table. So we have a pickup time, we have H3 index, and we have a number of pickups. And if in initial table we had how many rows? We had around 150 million of rows. Then after doing this bucketizing, we are getting the table that contains much less rows. It's only 30 million of rows, 31 million of rows. As a second step, we want to enrich our data with crime statistics. And for this, we also will use a data set that provided by CARTO in our marketplace. If we look for USA crimes, we will find this data set, crime risks. And if we look into this data set, it will look like this. Different fields represent different types of crime. In my case, I'm interested in total number of crimes. And we have a geometry field, probably the most important one, that splits the area in census areas. And if we count the number of rows in this table, it will be about 100,000 of rows. As a next step, we want to join those two data sets. And to join them, we will use Geospatial geofields. How I will do this? I will take the center of the hexagon from my table with transactional data and join this with geometry field using st within statement. And in order to get the center of the hexagon, I will write my own Python UDF. So I will, in this Python UDF, I will use H3Py library and Shapely. And actually the code itself, it's like just 5 lines of code. And after running this SQL statement, which is quite complex one, I would say, because like you can see here, we take in 2 tables, one table 30 million of rows, second table 100,000, and then we run st within. And as a parameters for st within, we take the Python UDF, which is H3 to geo, where we take the hexagon and return the center of the hexagon. And in order to speed up this query, so we don't use the whole data from the whole USA crime statistics, I will apply this where clause, and I select only areas that belongs to the city of New York. And after running this query, I'm getting this result. So I have a pickup time, I have a H3 index, number of pickups, and number of crimes. And with this information, we already can start training our model. And with this, I am over to you, Thomas.
Thanks, Alexei. That was really interesting. So let me share my screen, and I will build up on this demo that we're doing. So let me just find my screen, and I will leave it this one. Hopefully you can see my screen now. And I am again sharing the Snowflake console, the Snowflake SQL console, and I will be building another table. So it's pretty much a really similar operation than the one Alexi just did. So we are computing the H3 cells for each pickup location and also drop-off location. And I'm doing so in a really high resolution. So this is, I'm using the H3 GeoPoint function, which takes the pickup location and a resolution, and it outputs the H3 index for that cell. And a resolution of 13 is a really high resolution. So we have hexagons of maybe around 10 meters in each side. And I'm computing also, I'm grouping by this H3. So every point that falls within this, this really small hexagon, I am counting all of the pickups that are happening in this hexagon without any temporal component for the whole of 2015, which is the full temporal length of this dataset. Then I'm doing exactly the same, but for the drop-off, and then I'm joining based on the H3. So what we get is what we can see at the bottom, which is the total pickups and the total drop-offs that we have for every H3 cell. And just to build upon Alexi's explanation on this H3, which is a spatial index, you will see now in the demo that I will show on the CARTO platform that we will be seeing the spatial representation of this data, even though we don't have a geometry in this table. And that is because the H3 is specifically referencing some geospatial location in the map. And the magic thing about this index is that we can compute some functions that are incredibly performant. So something like computing the childs of this. So we have a resolution 13 and we want to compute the child, so the resolution 15 maybe. So computing the childs or computing the parents, for example, so taking what is the H3 of the resolution 10, for example, that is incredibly performant. So from this, I will jump to the CARTO platform. So this is the CARTO workspace. So this is what you will see when you log in to CARTO. And this is where you will manage all of your CARTO resources and hopefully all of the resources that you will need to solve your spatial problems. Now, just to mention, there is a 2-week free trial for you to go into the CARTO homepage and log in, and you can test all of the queries and all of the tests that we will be showing now with your own data and with your own Databricks connections. So typically, as I just said, typically the first thing that you will want to do when you log into CARTO is to create a connection, because you want to be able to access your Snowflake database with your computer resources and with your data storage. So from connections, I can create a new connection. In our case, I have already pre-created this SFCon, Salesforce connection. And if I click edit, you will see all of the parameters that you need to put in order to create your connection. And once that you have this connection, you can establish a direct link between CARTO and this specific user that has some privileges and some rights and permissions. And you can go directly into the Data Explorer section. So in here, you can explore your data. And something really cool is that you can explore the local context of your data. So right now you can see I have 2 connections. So I can expand on this Salesforce connection. And if I just look for the NFL, which is my instance, and then I go to dev, which is my database, I have all of this data. And if I go to all rights H3, which is the table that we just showed the SQL for that, we can see that we have some data preview. So we can see the table representation of this. I only have drop-offs, total drop-off, total pickups, and an H3 cell. And I have a map view of the data. And this is what I was saying. We don't have a geometry here. However, we're able to visually see the spatial representation of this index on the map. Now, let's try to follow on Alexi's use case on trying to understand the distribution of crime risk and also the distribution of rights that are happening on New York. So if you go to crime risk, we will see the same table that Alexi was working on, which is a 106,000 rows and a 200 megabytes table. And I am denoting this specifically because if I click on create map, we will be able to see this will prompt us with the builder tool, the tool that I mentioned that help us create these dashboards and this map analysis. And for sure, I don't want to load 200 megabytes of data into my map application. So what CARTO does really cleverly here is it leverages Snowflake's computing in order to do as an intersection and to create a vector tile that is rendered on the screen. So if I zoom out, you will see that the data appears to load by tiles, as you might see in some raster applications, for example. So if I move, if I pan through the map, you will see data loading as I zoom into this area. So if I zoom into New York, you will see that I will only get the data when I pan into this map. And what is happening is that this application is throwing a query into Snowflake, creating a dynamic tile it is creating the vector tile on the go and fetching the results into my application. And this allows us to have massive scale visualizations. So a table of 200 megas wouldn't be able to be represented in a map like this without a feature like that. So again, builder tool. And we have imported one source, which is our crime risk data table, and we have one layer. So let me just rename this to crime. And what we can do is we can click on this layer and we can decide how we want to represent this layer. So for now, let me just change the stroke color, and we can also make it a little bit thinner so it looks a bit better. And what we want to do is we want to use the polygons to represent some feature. So what I can do is go into the field color and decide how I want to represent the field color. And I want to color that based on an attribute. So in this case, I will use this variable, which is the number of car thefts that happened on each one of these census sections. And when I do this, I can decide what color palette I want to use. So let me just decide this one, and I can also decide how I want to classify this data. For now, let's just leave it as quantile. The other thing that I might be interested in doing is not seeing at every census section, but rather filtering for the census section with highest rate of crime. So I can go to the widget section, and I can create a new widget that will allow me to interact with this data. So let's just rename this again to crime histogram, because I will be using a histogram widget. We have many different types of widgets. For this, we want to show just the distribution of the crime risk. And we also need to provide a unique identifier for the geometries. We can define how many buckets we want and how we want to format the labels here at the bottom. So we have a lot of features, a lot of polygons with not so many risks and not so many cars being stolen. So I want to just select the ones that have a higher risk. And I want to see how this correlates spatially with the drop-offs that are happening that we have in this data set. So I want to add another layer. Now, rather than going to the data explorer, I can add a new source from here. And I can just select any of the given connections that I have previously created. For now, let's just use the connection that we have pre-created. And I will go to the Edenfeld, which is my instance. And again, same structure, my database. And I will look for my table, which is the all rights H3. Now, this will let me know that this is an H3 index table, and it's letting me, it's informing this to me because you will realize that when I add this table, something rather strange will happen. So if I zoom out, you will see that the resolution of the hexagons is actually changing with the zoom level. And this is completely intentional because for this visualization to make sense, what CARTO is doing is for each zoom level, we're showing the data aggregated at a different H3 resolution. And it will be much clearer when we actually show that with, again, showing some feature of each of these H3 cells. So let's just rename this to drop-offs. And if I click on this layer again, I can select how I want to fill this color, but rather than selecting an attribute, now I need to select an attribute and an aggregation method. So in our case, we want to sum the total drop-offs happening on each of these H3 cells. Now this will again throw a query to Snowflake and output the results of these aggregations. And these aggregations are what I was meaning before, that these are crazy, they have crazy performance. They're really, really fast. So let's again just decide, let's use another color palette. Let's select logarithmic scale. And let's drop the stroke color because it looks a bit better. Now, it will be really clear to see how the resolution changes if I change the relation that I want between my zoom and my resolution. So if I increase this, I will have a higher hexagon resolution. And you can clearly tell that now we can start to see some spatial patterns. I can even make this much higher, and this will be really small H3 cells. And I can see how I'm having more drop of concentrations in the city center. But let's just leave resolution 5 for now. And I'll just do a few more things. So let me just change the base map to dark so we have more contrast. I'll toggle dual map view, and I want to see the drop-offs on this side and the crime risk on this side. So I can start to see if I want to focus on any part of the map and to understand what is happening on the drop-off at that specific part of the map. Now, one last thing, I will just sweep to this next map, which is pretty much the same information, but I have configured it so that we can see actually what is the boundaries of the polygons that we're seeing at the same time.
That's actually interesting. And what happened? Like, is it possible to see what are there, like geographically, for instance, what are those areas? Are parks or something else?
Yes, so if we can actually change the base map as I did, and I put thanks Alexi for the question. So as I just changed to the dark base map, we can actually use many different base maps. And in this case, we might be interested in seeing this with a satellite view, for example. And we can start to see the difference in here, for example. Like we can really start to see that there's a clear pattern that vehicles are not really going to this area, which is a high risk area, which might be interesting analyzing. Of course, this needs to be normalized with population and with other variables to make this a really meaningful analysis. And on some other areas, such as this one, for example, we're having, it doesn't maybe makes a lot of sense, this analysis, because we're really showing maybe a park or some other area that might have cars stolen, but of course we won't get as many drop-offs in those areas.
Yeah, that's what I thought. Actually, like this might be interesting, for instance, for someone, I don't know, maybe not for ride hailing, but for like scooter providers to know where not to put, in which parks not to put their vehicles.
Exactly. That's exactly right. So let's continue with the analysis. And actually, let me go to the workspace again. And right now, I'm going to the map section where I have a few maps that I have created, and I want to create a new map because I want to show you how we can create a map from a table, but we can also create a map from a SQL directly. So this is a new builder map that we're seeing. And right now I can add a source, but rather than select a pre-computed table, I can actually select a custom query. And what I can do is I can, if I select this query in here, I can just pass it this query. And this will just shoot this query directly to Snowflake and get the results. So I can even do SQL analysis directly from this tool and see the results on the go. Now, on this case, what I'm doing is I'm trying to understand the city dynamics. So what is the relation between pickups and drop-offs? And to do that, I'm calculating a normalized difference. So a normalized difference means that I'm doing pickups minus drop-offs divided by pickups plus drop-offs. And this means that when this will be a distribution that will go from -1 to 1, meaning that -1, we're only having drop-offs, and 1, we will only have pickups. So let's see what happens if we run this analysis. Again, this will show this will throw the query to Snowflake, and it will output the results. And this is an H3 table, of course, because I have my index in here. So let me just zoom out. And again, as we just did earlier, I'll rename this layer. I'll put norm, or like pickup drop-off norm difference, something like this. And I can enter it and start styling it. So I want the field color in this case to be the average normalized difference. I want to drop the field color. And in this case, let me select a diverging color palette from, let's say, red to green, but in burst. and I want the color scale to be quantized. And for this to make more sense, let's increase the spatial resolution. So what we will see now on the map is what is our relationship between pickups and drop-offs happening on the map. So one more thing that I will do is I will add a widget as we did just before for the average normalized difference. I can format this again so that it looks nicer here in the labels. We can see that this is a distribution between -1 to 1. And I can even play with the colors for this representation to make a little more sense. So I can, instead of this palette, I can select a custom palette. Sorry, Instead of quantize, I can select a custom palette. And let's actually make this from 0.5 to -0.2, and I will do this until I'm happy with the results. Now, in order for the interest of time, let me actually change to this analysis, which is the same map that we were just creating, but it's a finished analysis. So what we're seeing here is a color palette that is indicating us that any value that is between -0.2 and 0.2 has a pretty normal relation between pickups and drop-offs. Now, wherever I have more drop-offs than pickups, we will be representing it with a red color because we're dropping off people, so we're concentrating people in that area. And where I have more drop-offs, pickups, than drop-offs, I'm representing that with green to inform that we're actually taking people away from that area. And this analysis is really interesting because it allows us to look into the dynamics on the city. And again, we can zoom in as much as we want, and we can see this at a really crazy high resolution. So the city center here, for example, looks gray because we're having a pretty standard relation between pickups and drop-offs. But if we see somewhere else in the map, we start seeing some interesting things.
There are definitely areas where we have more drop-offs. There are lines, there are the whole streets where we have more pickups than drop-offs. Those that go across the Manhattan.
Yes. It's really clear to see that people are actually taking, so the pickups, which are in green, are clearly happening on the avenues, and the drop-offs looks to be in more residential areas, so in these sideways streets, which are more residential. And there's a lot of things that we can start to see from this. So in here, for example, we can tell some sort of heat map of where the drop-offs are happening, and this informs us of where are some sort of point of interest in the lower part of Manhattan. So where is people dropping off to see some, and this is surely related to tourism, for example.
Can you show what's happening in the airport, for instance?
Yeah. That is actually really interesting as well, because you can even tell the internal dynamics of the airport in here. And of course, the histogram that we're showing, it's always being updated with the map extent. So we can decide to see where we're having more drop-offs and where we're having more pickups.
So drop-offs are more concentrated probably near the entrance to the terminals. When people leave in the airport, they can walk like, I don't know, 100 meters or 50 meters to get a taxi. But when they come into the airport, they probably dropping off near the entrance to the airport.
Yeah, it's really clear how the drop-offs are happening in these two entrances, but the pickups are much more sparse. So the dynamics are really clear to see through this analysis, leveraging, of course, Snowflake capabilities, the spatial index, and CARTO visualization.
That's really cool.
To wrap up, let me just go back to the presentation. I'll just share the screen. Can you let me know, Alexi, if you can see the presentation?
Yeah, I can see your screen.
Awesome. So to wrap up this webinar, we wanted to mention a real use case that is leveraging the power of Snowflake and CARTO, which is Deliveroo. Now, Deliveroo is an online food delivery company, and they came to us with three problems. They wanted to understand how to optimize routes. Sorry, I didn't mention. They have three sort of clients in the way that they operate. They need to get restaurants in their application, they need to get drivers to deliver the food, and they also need to get clients. Now, currently they have about 115,000 restaurants, over 100,000 drivers, and then, of course, many more clients. And they came to us with three problems. First, they needed to understand how to stack orders in order to optimize routes. They also wanted to understand how to address marketing campaigns for expansion, and also how to perform geographic segmentation as well to target, for example, marketing campaigns and out-of-home advertisings, as well as understanding where they should expand and how to plan their expansion campaigns. So I wanted to show this not only to demonstrate that this technology is being used for human mobilities with companies right now, but also that there's many other use cases that can be leveraged through this technology. So some things like real estate, retail, network expansion, out-of-home advertising. There's many different use cases that can be solved through Snowflake processing capabilities, CARTO's geospatial analysis capabilities, and the data that you can use to enrich and find the answers to these spatial problems. And with that, we have finished with the content of the webinar. So hopefully this was really interesting, and we will be opening now the Q&A. Let's see if you have some questions. We can.
It was really cool visualization, Thomas. Yeah, thank you.
Thanks, Alexi. So, okay, let's just go them one by one. So can I import in Snowflake formats that are different from WKT, WKB, GeoJSON, for example, shapefiles? Alexi, do you want to cover that?
Can I import in Snowflake formats that are different from WKT, WKB, okay, so in order to import in Snowflake data that differs from the format that we support by default, you can use Python UDFs, for instance. And today, like in this question, I see this, they mentioned shape files. For importing shape files, you can leverage Python UDFs. You can access Stage. Stage, it's a place where you put files before ingesting them into Snowflake. And with Python UDFs, you can access Stage, read data from there. From shape files, you can create a data frame, and this data frame you can ingest as a table. Yeah, so answer is yes. It's possible, and I think we even have a code sample how to do this.
Awesome. To add to that response, if I go actually to the workspace, one more thing that you can do through the workspace is when you have, if you have a connection that allows this, so you have the right permissions, you can import data using this feature. And we tolerate some of these formats, so you can load a local file, and then you can push it to a Snowflake table. So definitely you can work with that. And again, to the presentation. Do CARTO functions work as well for the geometry data type? So right now, all of what we showed was geography. So in projection 4326. Geometry is not yet supported, but it is in the roadmap and will eventually come.
Maybe to add this from my side, today you can apply workaround if you need to work if you need access CARTO Analytics toolbox when you use geometry. You can convert geometry to geography, apply some function from CARTO toolbox, and then convert back. Maybe not the optimal way until native support will be implemented, but it's still possible today.
Are the CARTO tiles pre-rendered, or are they calculating statistics on the fly and rendering the statistics rather than the raw data? So really good question, because we did cover this in the demo, but we actually covered the dynamic tiles. So we can either work with dynamic tiles, which works really well with this, with specifically that table. So tables around 200 megas, 400 megas, and around that. If you have a really massive table, let's say maybe a table that weighs 10 gigabytes, for example, you can create static tile sets. So what you can do is through CARTO, you can use one function of the analytic toolbox to compute all of the tiles, the vector tiles, which are stored, processed, and stored in Snowflake. And then you can render that at crazy speed in a web application. So we have tested this for over 1.5 billion points being rendered on a map. And the performance is incredible. Is it necessary to work directly in SQL to perform spatial analysis? So you can do it in both ways. You can use the Snowflake platform directly, and you can write SQL code in the platform. You can also use the SQL console from the Builder tool, but Builder is also aiming to be a low-code tool. So for non-as technical users, we actually have some geoprocessing functions that you can leverage through the UI. And under the hood, this is really writing the SQL for you. So some things like, and maybe if I have this open somewhere over here, so let's just put this map, for example. If I have this map, I can just go to the Scrum risk and I can add a SQL analysis. And this will prompt me with a few analyses that I can run. So I can intersect and aggregate, I can create buffers, I can do some clusters, compute centroids, find trade areas. So some analyses are already available, and more are on the roadmap. So yes, we are aiming for both really analytical users and also for less technical users. Can you convert between spatial reference systems, for example, 3395 to 4326? Alexi, you want to cover that as well?
Convert between spatial reference systems. Yes, that is possible. Today, you can do this by leveraging Python UDFs that I was mentioning today throughout the session. You can create a function that will do these transformations. Currently, we are working on native support for ST transform, and we plan to go into public, not in public, in general availability with geometry with native ST transform. Yeah.
Awesome. Is it possible to share the dashboards created by CARTO? So we will share content. We will share the content in the next few days. You will get some content out of this webinar, and that is one of the strengths of CARTO, really, because all of the dashboards that we created, it's really, really easy to share them. So once you create a dashboard, you get a whole section where you can configure how you want to share that dashboard. So you can leave that as a private map. You can share that across your organization, and you can even make it a public map, or you can even configure what features do you want the viewers to be able to do with that dashboard. Do you want them to be able to zoom in that map? Do you want them to be able to download the data that's available on the map? Do you want them to be able to use the geocoder tool that's at the top to be able to search for an address? So there's a lot of configuration that can be done. So you can create a map and share it with your colleagues, other teams within your organization, and even make that a public map that you can share with an iframe or any other way. And last one so far, can you share the example of Python's UDF for transformation between streets? And Alexei, I think that's yours.
Yes. Yes, we have a repo in Snowflake Labs where we have examples of some functions, like for instance for ST transform, for ingestion basically from shapefiles. We also have code samples, so I can share it. Yes.
Awesome, great. And if there are no further questions, we're just about in time. Perfect timing, almost, I would say. So hopefully this was really useful for everyone. Happy to be sharing all of our material with you. As we said, we will be sending some of these materials through emails in the next 3 or 4 days, probably. And yeah, thanks, Alexei, for your help as well.
Thank you, everyone. Thank you, Thomas, for the invitation.
Thanks, everyone. Take care.
Bye-bye.